I think this is probably one of the most interesting um, lectures of the semester. It's jammed with information, so I am recording it. We'll upload it after we're done. But I have questions for you guys, so I need some interaction. So deal with me for like 30 minutes, talk back, whatever you need. But I'm gonna ask a couple simple questions, and or I think they're simple, but we're gonna just draw on my handy old MS Paint. And I always draw these two boxes usually, and one's like client, okay, the browser, or your laptop, whatever, right? And this one over here, I usually put like server. And our goal by the end of this class is to understand, what that node modules folder is, because I don't think that's ever been explained. Um, we're going to also program our own web server, which is kind of cool because um, up till this point, we've been just using web servers, right? We've been using npx light server or whatever you guys used in Web 2.2.2, but now we're going to program one. But the first step before we do any of the coding for this stuff, my major question is how does the internet work? And if you've never really thought about it, and more specifically, I mean, how does my browser, when I open it, how does it know or where to go when I type CNN.com? Does anyone know how that works? How does the internet work? Any ideas? Yeah, router, DNS. Well, those are good words, but explain. HTTP. Yeah, what's HTTP? I guess it's a protocol, right? But what are these words? Like, what does a router do? Right when you log into your wrote the packet. And I'm if you're wondering where these questions are coming from, it's the Zoom chat. You can also ask in Discord. I have both of them. Wrote the packet. Yeah, when you connect to your Wi-Fi um, at home, or you plug in a network cable into your computer, what happens? Someone says DNS to get the IP address, then client browser uses that IP to go to the server. Yeah, that's pretty handy. That's pretty exact. But think about your router, right? So we have a router down here, and we know that well, hopefully you've seen this before, but if you open up in Windows command prompt and you type ipconfig/all, I don't have Windows on here, but you should get a screen that looks like this. And it should tell you a bunch of information: default gateway, DHCP server, IPv4 address, your external IP address, all of this kind of stuff. But where does this come from? Right. And in order for us to program a web server, we have to have a basic understanding of how this stuff works. And like some people don't know. And it's not, I had to learn this by just doing this stuff. And in fact, I'm not a networking expert. And this is, I don't think you guys have a networking class, do you? Is it, do you guys have a networking class?
Not
No.
that I know of.
No, okay, that's so like I didn't either. Wait, maybe I did in university, but I kind of had to figure a lot of this stuff out. And networking is not as easy as everyone thinks. Anyway, when you boot up your laptop, um, and you connect to Wi-Fi, typically it's a router that has, you know, Wi-Fi built into it, and your router gives your laptop an IP address. And next question is, what is an IP address? Like, what is that? Yeah, like I can Google it too or chat GPT too, but off the top of your head, what does an IP address do? What's it? What is it? What's IP address? Like what's it even stand for? Yeah. Internet protocol address, right? Okay. The address of the device on the local network. Yeah, well, it can be on the local one. So speaking of local, typically when you connect to like a network, hold on, let's just do it over here. Oops, zip this in so you can see it. You should see some addresses that kind of look like this, right? 192.168 dot whatever, 10.0.0.1, 127.0.0.1. These are all local IP addresses. But when I say local, it means that I can only in only devices that are connected on the same network would receive these IP addresses. And when you connect and you see that screen, where did it go? IP config. Right? If you have like if you're sitting in the school, all of your computers probably have an IP address that's similar in the last, you know, 3 digits are changed because we all get unique IP addresses. But these ones will never go online. They're only just in your router's network. And then you're like, okay, or your laptop's like, okay, I need to connect to the internet. So typically the router connects to a modem, or again, you get an all-in-one unit modem. And the modem is just like a basically a router that connects to an ISP, internet service provider. Right? And that's like Rogers, Bell, oops, Rogers, Bell, whatever, right? The school's network, blah, blah, blah. And Rogers and Bell have bought outside IP addresses, and they can issue them to us as like users of the internet. And specifically, they will issue it to our modem. So you probably have an outside IP address, so you don't share it or whatever, but it was like 2.4 whatever, whatever Bell and Rogers have, right? So they give it to our modem, right? And then the modem sends its information back to the router, and the router sends that information back to your laptop or whatever device is connected. But basically, all of the devices that are in your network are sharing this one IP address to the public. The router will assign each of our devices uh, different IPs. Now, this answers the question of where does the IP address come from, and we kind of have a connection to the internet, but it does not answer the question how do I how does my browser know to get over to this server? And more actually, let's ask this question. What's the difference between a server and a web server or a game server or a database server? What is the difference between a server and these things? Different protocols, kind of. Um, what else? Type of information stored, kind of. But let's be more specific. Actually, I'll just do what's the difference between a server and a web server? What's the difference there? Different functionalities. You're thinking very software-ish, but like what's a server in general? Serve stuff. Yeah, I guess that is correct. Hosting platform, right? So servers are typically physical or are physical computers, right? And if you ever heard of like your parents or whoever, they're like, my stuff's stored in the cloud. Like they really don't know where their stuff is stored. But even a cloud computer is a physical machine somewhere. And in fact, I used to run a web server when I was in college, and I used to sell my classmates hosting space because this is in 2005 or four or whatever, and there was no cloud services. And I had to actually buy a computer, and I remember I would take it on the bus and go to the hosting provider, like the ISP, and I would have to, they'd have racks and everything in there, and you set up your hardware and you can host people's websites. But I'd have to take the bus home, and then if the something happened to the server, if it crashed or whatever, I'd have to jump back on the bus, go down to the ISP, and screw around with the server. So these are like physical servers. Now you can get these cloud machines where we don't physically have to be there. We can remote desktop into. But a server is typically just hardware. So whenever you hear someone talk about a server, that's the hardware that's driving whatever the other thing is that we're running. Now, web server, game server, database server, these are all software-based servers, right? So someone mentioned different protocols, and we'll come back to that in a second. But really, that's kind of the difference. So when you mention a server, your laptop, in fact, today will become a server, right? So the server is the hardware, and then whatever the software is, web server, game server, database, whatever, is the software server. Pardon me. So question still remains when I open my browser and I want to request CNN.com, which is on a web server, right? We know also that, or like, how do I get here? And just remember, our laptop can be a server, and the actual web server follows this exact same process. So it would connect to a router, which then eventually would connect to a modem and would eventually get an IP address, and then it'd be available to the world. So this server for CNN, for example, would have, an IP address of whatever it is. I don't know, 23 something, something, something. But when I type in the address into the browser, I don't type in 23.23 to whatever, whatever. I just type CNN.com. And someone in here mentioned DNS, and that has something to do with it. But what is DNS? What is DNS? What does it start by? What does it stand for? What is DNS? No one's heard of that before. I'm assuming if it takes you more than a second or two to answer, then you're Googling it, but that's cool. What's DNS? Domain name system. Good guys, don't name, don't domain. Oh my God, I'm having like a brain aneurysm. Domain name system, service, server, sometimes interchangeable. Changeable. DNS is like a phone book to get the IP address based on the name. Yeah, that is a very good example. Sometimes I like to say it's like a spreadsheet as well. It is a database technically. So a DNS server, if you look back at this screenshot of your IP config/all, you'll notice there's a DNS server, and sometimes it says primary and secondary, and there'll be two IP addresses in there. And what happened was Rogers and Bell, they have a DNS server, and it's like a list. So on the left side column, it has every domain name ever created in the world for every website. It doesn't matter if it's .com, .ca, .net, .xxx, whatever, it has it. And then on the right-hand column, it has all of the IP addresses. And if we recall, and I should say this, all IP addresses are like, they call them address literally because it's like the address of your house or the address of the building that you're in, right? So there's not two of the same address because then we wouldn't know where to go. Anyway, so we have this huge database list of all of these public IP addresses. But it would be, again, terrible to have to download this entire list from the entire world, right? Millions of websites into your browser. That would be a terrible idea because your computer really, what's the point of that? So Rogers and Bell keeps this down on their servers. And there's other ones. Google has some. I use Google servers. But what happens is when they send back this public IP address to you, they also send back their DNS server. So that's how this DNS server gets populated. And it comes back to your router and then eventually goes to your browser. So when I type in CNN.com in the browser, the process is actually going, hey, I'm going to ask my router, my modem, and then Bell what the address for CNN.com is. It comes back to the modem, back to the router, back to the client. And then the browser, it just doesn't tell us the IP up here, but it actually uses it to do this first connection. So it's a huge process of how that all works, which is, sometimes you don't think about that, but that's exactly how it works. And it's also, if anyone in here has bought a domain name before, and you likely will in the future if you're staying with CompSci or whatever, you may notice that it can take 24 or 48 hours for your IP address to become public. And, or more specifically, it can take 24 to 48 hours for your website to become public, because Rogers and Bell are not just the only people that hold this list. It's every ISP holds this list. So when CNN decides, okay, we're going to upgrade our server and we're going to change the IP address, it has to go out to every internet company in the entire world and say, hey, I have an update for this DNS. And they call this propagation. So it goes through each, one of these servers, and it can take a while to happen because it has to trickle out to every server in the world. And these servers, maybe they're not updating every minute. It's a lot faster these days, but um, I've seen it happen in 30 seconds, but I waited almost 2 weeks once for a DNS propagation, which is pretty crazy long time. Anyhow, I think it's cool how it works. This is like a basics, outcome of how this networking stuff works. But what I want to concentrate on is this connection. So I'm going to erase these other lines that I made here. Go back to the start. And just assume all of that router and DNS stuff is happening, but I want to concentrate on this. Oh, shit. Not that. There. Why is it doing that? Great. So this line right here. So someone mentioned earlier protocols, HTTP, telecommunication, Ugopoly. How do you say that? How do you say that? Matthew. You're running back to the computer. Ugopoly. I can't even say that word. It's like Monopoly, but oligopoly. Okay, I was gonna stop now. You guys are awesome. Okay, so I'm confused. Right, this line. So someone mentioned earlier HTTP protocol. I won't ask, hey, what's HTTP stand for? Hopefully, hypertext transfer protocol and hypertext, right? HTML, hypertext markup language. Did I show you guys the world's first web page? Did I ever show you that? I'll drop it into Discord. May have showed some students last semester. Yeah. But if you haven't seen it, jump into Discord. I'll drop the link. But check it out. This is the world's first webpage. And yeah, it was created by CERN, the same Hadron Collider that everyone thinks that we're in alternate universes and all this crap. That CERN. So check out this website. Like, it's pretty basic. If you right click on it, go view page source, you can see, all of the HTML and stuff in here, header, title. It's not even valid HTML, really, because, when CERN, the people at CERN, when they invented web pages, they didn't have servers. They also invented web servers, right? And they also invented how that communication happens. And as they're doing that, they came up with names for stuff like HTTP and how this protocol, is supposed to be laid out. And talking about the word protocol, what is a protocol? Well, like, what's a protocol? Any guess? But it's fun. Set of rules, yeah. I like system, instructions. Those are great answers. Like, protocol is basically the rules, right? So we can send data. We could actually send any data we want across a wire, right? 10011, whatever. But if it comes in a certain form, then we can capture that data at another end. And as long as the two computers follow those rules, then they can talk to each other. So these are protocols typically. HTTP, HTTPS, we'll talk about these two today. FTP, SMTP, um, you know, there's tons. RTMP, streaming, all these different kind of protocols, right? So we could have, the protocol for the web server might be is very different than, say, a Fortnite server. Anyone play the new Fortnite? No. Cars are pretty crazy. Um, so we have this HTTP. And inside of HTTP, we've given this line a name. And when I say we, I didn't do anything, but the people that invented this gave it a name. But before I tell you the name, I want you to go back to this view source and think about HTML, right? So they had to invent web servers, they had to invent HTML. And they did this at universities because they just strictly wanted to share data. And the data at the time was like documents, thesis, documents about the Hadron Collider, whatever it was. They weren't sharing memes of whatever stupid stuff that we have today. And if you think about HTML, it uses some strange words like header, title, body, H1, like header one, paragraph tags, index, right? We call it index.html. And they derived all these words from basically word processing documents like Microsoft Word or Word Perfect way back then or whatever, because that's what they did. Like they were just trading data. And if I wanted to get data from another professor at a different university, I'd have to request it. And so they call this an HTTP request, and it's called a GET request. And it's literally, they came up with the word get because I'm going to go get some data. Right. So this, when I type in anything in the browser, CNN.com, the first web page, Google.com, whatever, every time I do that, it is always a GET request. Right. Now, when you upload your assignment to Blackboard, when you upload a TikTok or an Instagram or whatever it is, we also have a word for this, and it's called post. They call it post request because if I wanted to send, a document to another professor, I mean, this wasn't me doing it, right? Like this is back in the ancient times. You would have to go to the post office and literally put it in the post, and then you can send that data. So when you're getting data, get request, pretty simple. And then, or sorry, when you're retrieving data, it's get, and when you're sending data, it's post. These are the two major HTTP methods that we're going to concentrate in this class and for the rest of the class, the rest of the semester. And I'm going to show you how to program these today, which is kind of cool. There are other ones. There's a delete, a put, and several more. You can check on Web 3.2 for the full list. But the two most used ones are get and post. Any questions so far? I know we haven't programmed anything, but again, this is kind of required so that you know what we're actually programming. No questions? All right, either you're all sleeping or you don't care. No, I'm just kidding. So other things that happen. Um, when I make this get request, you can actually look at these when you open up your browser. So if I go into use an easier one. So web322.ca. If I right click, inspect, and go to the network tab, and if you just refresh the page, you can actually see all of the network requests. And in here, there's other data that goes down this line. So I basically do a get request. I ask for web322.ca. The server says, hey, yeah, we have that. And I'm going to send it back. And the server sends back a bunch of information, but specifically the data that we get for this web page, for any of these web pages, just comes back as a string. And we call it a body. But also included in this are a slew of other types of things. And one of the major ones is the status code. So status code of 200, it's really strange, but that actually means everything's okay. So when we receive when we receive the data back from the server, it could be anything in there, but the server is saying, hey, this is okay, 200 okay, for your browser to render. Pardon me. Right. So this is before we even render the whole page, because maybe it's the data is not good. our browser will actually check, oh, is this okay? The server says it's okay. So now we're going to render it instead of wasting its time, rendering something that may not work. But other interesting things like the Web 322 site. Hold on one second. Sorry about that. But check out this. Like, when you think of getting these requests, most people think, oh, I just make the request to CNN.com and I get the entire website. Well, that's not what happens. Same for Web 322 or same for any site. So what happens if I let's do web322.ca first. And if you look at all the codes, so first of all, whoever made web322.ca, they decided that they're going to change the URL to web programming tools and frameworks.sdds.ca. Yeah, that makes a lot of sense, right? Much easier than web322.ca. But notice the status code. So this has a status code of 301, which is it looks like move permanently. And then this is what is sent back. So to our browser, 301 instead of 200. And our browser goes, oh, we're not rendering a page yet. I need to go to this other website and ask for that data again. So that's what our browser does. It says, okay, I'm going to go back. Right. And we look back here. And the next one is, okay, this is okay. So we send back the HTML to our browser, and the browser starts rendering the HTML. And the first thing that the HTML has in it is a styles.8a33ef.cs. So another HTTP request is made to the server and says, do you have this file? And says, yep. Comes back to the client. And so on and so forth. You can see there's the logo, different version of the logo, probably for when it's minimized, until we get to the end of the page and everything has been loaded. And each one has a status code. So, there's hundreds of requests happening. And I always show the CNN. I'm sure I showed you guys this before, but check out the network requests for CNN. When you refresh this page, right? Like the page is loaded, but it keeps going. And look at how crazy that is. In fact, if you leave your CNN tab open, you can download gigs and gigs of data. And that's typically I'm bad. I'm really bad for leaving tabs open. Like I have 14 browsers, but you shouldn't, especially if you're concerned about data. If you're on a hotspot, right? This is still going because it's constantly, there's some JavaScript in there running the background that does stuff. But anyway, so every one of those requests is one of these lines that go back and forth. Makes sense? The last thing before we actually program this stuff, we go back to the easy one. If you click on some of these requests, like for example, I don't know, this logo, it will tell you more details, and they call these the headers. So it tells you specifically, what the IP address is of the server, what port we're on. Oh, we didn't talk about ports. We'll come back to that in a second. And, the status code, other things that are like hidden in there. When the page was created, when it was last modified, the server's actual name. It looks like they host this on GitHub. It also tells us stuff like our browser information. What did we visit that website with? So there's lots of kind of hidden stuff in here, and you can see other types of information, like how long it took me to download that, and so on and so forth. So I guess there's one more thing before I actually show you how to code this, but question. Let's just get rid of this. So I send a GET request over to our web server, but our web server hosts a Fortnite server, a Discord server, and I don't know, database server. And I'm sure you're going to know the answer to this already. Oh, shit. Discord, sorry, database. Because I kind of spilled it because I was like, oh, yeah. But how does our GET request know that it has to go to a web server? You should all know the answer because I said it. Yeah, port. Thank you. Right. You're so smart. Right? So think of the port. The I'll go back to this. A web server is on how do I say this? It is the most common for a web server to be on two ports. HTTP is default port 80, and HTTPS is default port 443. So when I was over here and I just had that, oh shit, I forgot to tell you that stuff moment, you can actually see the remote address of the web programming tools and frameworks sdds.ca is this IP address, and it's running on port 443. So if you're not sure what ports are, think of them as the apartments in the apartment building, right? So if our IP address is the apartment building, then a port is the apartments, because our Fortnite server doesn't care that I want to get the CNN webpage, right? And if I didn't, you know, if I didn't knock on the web server door, all of these servers might respond, and they don't know what to do, right? Like Fortnite's going to respond, Discord's going to respond, database is going to respond because I asked it for something and I wasn't specific. So we assign these ports, and it's how we can have multiple servers, multiple software servers on one hardware server. And this comes into play when you're making websites and you go into the real world and start to make stuff. You don't just, change the website and then upload it to the live website. Sorry, you don't change your local computer stuff code and then upload it to the live website, right? Because you're probably working on like a huge company and the boss wants to see the changes before it goes live. So we typically send it to like a development server. Well, smaller businesses, and in particular, when I was a student and I had to go down to on the bus with a server, I just put my development server and my web server on the same actual hardware. So I would have two servers running. And you may have seen this before when you have been running websites, you might see HTTP localhost 3000 or something like this, or 8080. And this just means, development typically doesn't happen on 80 or 443 because those are production. They're saved for those production. You can make a server on that if you want, but you would typically that would be public for the rest of the world. Interesting tidbit of information. The entire world now, well, 99% of websites run on 443. But this also means that you need to buy, or you can get one for free, an SSL certificate. This is not a networking class, so I'm not going to tell you too much about this. But what happened was everything before, say, 10 years ago, really just ran on port 80. And this means everything's unencrypted. So we could actually, what we used to do is we'd sit in the library of the school. And once we were connected to the network, we could see everybody's login for Facebook, because we would just fire up Wireshark. Every packet in this, when you're on someone's Wi-Fi, comes to every computer, and we could actually just see logins for all the systems. It was a crazy time if you were in comp sci, and this is a bad thing, right? Because then I could actually just log into your Facebook, your Instagram, whatever. Well, no Instagram back then, but everyone recognized this, and encryption was made, and that's why we have HTTPS. So now the traffic's encrypted. You can't read it as easy anymore. But on that note, on this 8080, it's interesting because I always say programmers are lazy, and we really are, but we're smart. So we code stuff so that, we can be lazy later. But since production was on 80, it was just as easy to type 8080 because you didn't want to move your fingers. And that's why like 90% of development servers are on 8080, because they would just go 80 to 8080. Anyway, doesn't matter. Now it's not relevant because it's on 443. But that's where 8080 comes from. Anyhow, questions? Any questions on that basic networking internet? It's very good, by the way, to know that little diagram that I just showed. And like you can find similar ones online, but it's a common question, especially as a full stack developer. of at some point you're going to buy a domain, you're going to have to put in the DNS entries. You're going to have to put in the IP address of the server. You're going to have to set up A records. You're going to have to set up MX records, like mail records. So that's before you touch a line of code. So it is a typical question, or those are in there, typical questions in job interviews. What's an IP address? What's a DNS server? Give me a basic understanding of how your client connects to a server. What's a web server? What's a port? Those kind of questions are very, very common in interviews. I won't test you on that stuff, but I did want you to know how that worked. All right. If there's no questions, I will move on to some code. So if you want to follow along, open up VS Code, and I'm going to drop the code I'm doing into Discord. It's also on the site under simple web server using Express, and it will be in the recording of this that I upload later. All right, so open up VS Code and just make a blank folder. I'll delete this index file. I'm just using week 2. I know we're on week 4, but I don't care what you name your folder at this point. So I'll give you like 30 seconds to do that. Okay, hopefully I want at least one or two of you to do this with me so I know that it's working. But you're going to have to do this, the thing that I'm going to show you right now, for every lab here on out. For the next 5 labs, you're going to do what I'm going to show you. And for the next assignment, you're going to have to do what I'm showing you. Now, I left you guys hanging a little bit with the Vercel stuff, and that's that I didn't check the requirements, but some of you ended up with folders called node_modules. And good for you if you figured that stuff out. But can someone tell me what is node_modules? Did anyone like look into that, research it, knows what it is? What is it? Dependencies? Yeah, what's a dependency? Sounds like a diaper, right? What's a dependency? I guess some people might depend on that. Extra libraries that you include. What's a library? What's a library? I like the words you're using. They're all correct, but what is it? What's a library? Node.js modules. Yeah, okay. What's a module? Scripts, library you install in the npm. Yeah, we're getting warmer. These are the correct words, but it's code made by someone smart. I'll give you that. I'll give you that. Um, I think I told you this once. And again, I have a Mac, but there's a folder on the Mac. I should find it. But if you open up File Explorer and you click on C drive and then go to System or Windows and then System 32. And if you go in there and you delete all those files, don't do that because you'll shut your computer off. But if you look in there, there's probably like 4,000 files in there. It looks something like this. And if you scroll through them, a lot of them are DLL files, and some of them are .exe files, and there's config files, but most of them are DLL files. And these are pieces of code made by someone smart. I think we're all smart. We're all programmers, right? Specifically, Microsoft made those ones. Mac, I'm not like a Mac OS expert or more Windows, but Mac has similar. But these DLLs allow us to have stuff built in as programmers. Specifically, in Microsoft, it always has the same minimize, maximize, and close button, right? Like in the top right hand corner. On Mac, it's on the top left. So I have the X, the minimize, and then whatever maximize. Well, every time we write a program, it would suck that if you and I had to program those, right? And if we had to draw that little graphic, or if I had to actually program this file menu and I had to make the mouse over event that changed the background to blue, it would really suck. right? Because they've already been done for us. So Microsoft made these available to other developers, such as yourselves, and they're called libraries, right? Just like going to the library to get a book, which I don't know, I haven't done that in 20 years. And other developers caught on to this and they started doing stuff like open source projects, right? And you can go into GitHub and download people's assignments from last semester. No, that's not what it is. You can go to GitHub and download other programs. And we do this as devs because we're lazy, right? But we're not. We could actually program those libraries, but why not share them, right? You wouldn't go reinvent the wheel because we already have an invention of the wheel. So let's let everyone kind of use that. So one place that these libraries are stored for Node is a website called npmjs.com. And there is a library that a developer created called Express. And Express is, hold on, let's just find out where my picture went. Right here. Express is, well, this ad is right in my face. Okay. Express is a web server um, framework, we'll call it. So if you think about it, if we had to program our own web server, we would have to code this get request, what happens when that gets sent. We'd have to program the request that gets sent back to our client. We'd have to figure out how to parse that data. We'd have to send in the status codes and all this kind of stuff. But we actually want, sorry, something just beeped in my head here. We don't want to do all of that, but we still want to have some control over this web server that we're creating. So Express has done most of this lower end work for us, which is great because now we can use their library to make our own web server. So anyway, npmjs.com, you can go check this out. There's similar ones for C#. It's called NuGet. Like 500 billion downloads of packages of software that developers just like yourselves can put on here. Anybody can put a package on NuGet. Anybody can put a package on npm. It's just whether or not people will download them or use them. Python, I think. Anyone use Python here? They pip, if I recall. Anyway, so this is nice of developers, right? And you can also sell stuff on here, whatever. Anyhow, so we're going to use Express. We're going to install this library. Node calls them modules, so I'm just going to call them modules from now on. Now, npm makes our life a little bit easier. No, like this would suck too if I just had to download, a zip file. Holy shit, 30 million downloads in a week. That's a lot. Okay? Anyways, if I had to download this and drop it into my project. So instead, we're going to use this thing called npm. But before we get there, npm also has templates for certain things. So when you made your Vercel the wrong way, it said make a, or I don't know if it was the wrong way, but it said make like a vercel.json file or something like this, whatever it was. And you might have ended up with a package.json file. So every node project that you have that uses other modules and that say you want to share with someone else or myself, you have to have like a definition of the actual project. So this comes in a file called package.json, package.json. And this will have information like the title of the program, the version number. And so that means if you ever uploaded it to npm, this stuff would automatically fill out, right? Like what license it is, how many files, all this kind of stuff. But it would suck again to like have to memorize that. And programmers are lazy, so someone made up npm initiate. Yeah, good question. What is package lock? Let me finish this and I'll come back to package lock in a second. So if you're following along, npm initiate, and this is a program. And think about this, npm initiate. It says this utility will walk you through creating package.json file. You could actually, like as developers, everyone in this class has the knowledge to build that program because this program is just collecting data and outputting a file. That's right. So this is something you could have written or may write in the future, right? Yeah, so you should start filling these out. I'm gonna leave my package name as week 2. If you're gonna do a lab from here on out, just call it the lab name, maybe whatever the assignment or lab tells you to do. Uh, Again, I'm just gonna leave it. The defaults are usually in brackets. Versions doesn't matter right now. Description, I'm just gonna do demo for week 4. entry point. So this is the main file, and we're gonna have multiple files in our project. This is the main file of our program. Typically in these node programs, they're called index.js. We also sometimes call them server.js. I don't care which one you use. I think I said a couple weeks ago that we'd be using server.js. That's what I'm going to use. I don't necessarily care if you use index or server, just use one of those. The rest we can kind of leave blank except for your name, license, and then you just say yes. When you do that, you should get a package.json file and with the data that we entered. So if you're following along, I'm going to give you, I don't know what time is that, 5:09, just 1 minute to get caught up. Do this initiate, npm initiate, and get that package JSON, and we'll come back in 1 minute, 45 seconds. Shouldn't take you that long. Okay, so hopefully you have that. Next thing, I would go download Express, but I'm going to make it easier because npm has something called install, which again, some developer, just like you guys, made this program called install. And as long as we type in the right word, Express, for example, like this package, right? Once there's an Express or whatever, let's say I had a package called Harry is awesome. I don't know, whatever, that would be locked in there forever. So Express, some shitty developers, they'll put in like Express with 3 S's, and then they'll make the code malicious and hoping that people with typos will download their program. See, here's one right here, right? 3 S's. This is probably a malicious package. So be careful what you type, but npm install Express. When it downloads, notice that we have node underscore modules now, and then package lock, which I'll come back to in a moment. But check out your package.json. We now have a new I don't know, whatever property called dependencies, right? That we talked about before. And this is basically saying our node program now depends on having Express installed to use it, and specifically Express 4.19.2, right? Our program depends on that. And speaking of our program, our main is server.js. So I also have to create this file. So server.js. And that's about it. Did anyone get that far? Please tell me someone's following along. Yes. Okay, cool. Okay, package.js. We are good. Does the package.json have to be in the same folder as the server.js? Yes, it does. Yeah. And I'll show you in a second. So should I tell you about this first? Actually, let's check. Let's do this. We'll come back again to package lock. Okay, so our program, our server.js file. Damn it, maybe I should have made it index. It doesn't matter. Server.js is in here, our package is in here. We have to rely on Express. So and obviously this Express, it's in the modules folder. We all know that. But if you open this modules folder, you can see there's a shit ton of folders, right? Which is like, I didn't download all of these. I just wanted Express. So let's go to Express, which is right here. And remember, JavaScript is not a compiled program, right? Or it's not a compiled language, it's scripting language. So we can see the source code. And luckily, these are all open source projects. But if you open up the Express folder, you can actually see it has similar things that we do. It has index instead of server, but it also has a package.json. And if we look in here, Actually, let's look in the lib folder first. In fact, let's look at index. So here's index. And to answer your question, Matthew, yeah, it does have to be in the same folder, but you don't have to put everything else in the same folder. So if you notice this index.js for this entire Express server program, it imports from the .lib folder, and that's all this code does. And that's probably because they wanted to organize stuff better. So yeah, anyway, if you open up the lib folder, and then you can actually see all of the source code for this software that we're going to use. And you can see typical stuff. You know, we don't make you put comments in your code because like I'm forcing you to. It's just so that, you know, these people can get credit. You know, maybe you'll make some awesome somewhere. And then you could actually go through this and find out how did they program the gets and the posts and the requests and what protocols they used. If they had proxy servers, you can see like this is all the stuff they programmed, right? But the interesting part, not that that's not interesting, but if you check out their package.json, these developers are also quote unquote lazy. And meaning, you know, they're smart people, everyone's smart, but why reinvent the wheel? So Express has a dependency of accepts, array flattener, body parser, all of these different dependencies. So when we installed Express, the npm will go to Express and be like, oh shit, we need all of this stuff. So it downloads accepts, array flatten, whatever. And if you go up to accepts, same exact structure. There's the package JSON, has all the people's information. And of course, this one also has dependencies. Oops, I broke it. Right? MIME types, negotiator. So it downloads those and so on and so forth until we actually have, you know, a full folder. So Express, in order to use Express, it has all of these other modules, libraries, whatever it is that is in there. Hopefully that makes sense. Back to this packaged dash lock. So this is automatically generated by npm. And if you think about it, package.json is like, how do I describe this? It's like the list of ingredients that you need, like dependencies, right? And then the package.lock is the entire list, a detailed shopping list of all the ingredients. And it's auto-generated based on all of the different packages. This is just an easy file so that it doesn't have to parse all of each directory in order to download all of the modules that we need. So I know that's like a mouthful, but basically this has all of the information of all of the packages that are being downloaded from Node or from npm. So if you scroll through this, you could probably find Express in here somewhere. Yeah, right here. And then it will tell you there's that accepts one that it has, and specifically what version, where it lies on the website, you know, an SHA hash, all of that kind of stuff. But it is auto-generated. So it doesn't matter if you delete these. Oh yeah, this is the next thing, right? So wait, first question. Everyone kind of understand this so far? Yeah,
Yeah, it makes sense.
cool. And did that clear, were things like, this was probably unclear before we did this, right?
Yep.
Okay, cool. All right. Last thing about this little package thing. So when you submit stuff to me from now on, I don't need package lock and I don't need node modules. And in fact, as long as you have your package.json, you can reinstall this stuff. And I don't have to know all of the things that I want to install. Like I don't have to care what, you know, your list of dependencies are. Like you wouldn't have to send me a list, so I have to type npm install express, whatever. All I have to do now is type npm install, and it will check the package.json and will just install everything for me. So when you submit stuff later, it's going to say, don't send me the node modules and don't send me package lock. The other thing that this is good for is, you know, it's not that like space is a commodity anymore. Like we have, you know, I have 8 terabytes in my basement on a server. Like it's cheap. But when we upload stuff to like GitHub or a private server that we're paying for, you know, maybe we don't want to store other people's code when we can just download it from something like a CDN, content delivery network. So we don't need these. And that's what, again, package.json is handy for. All right, that was a lot. Let's see. What's we still need to program something. What time is it? 5:20. Anyone know when this class is over? Oh, we got lots of time. Okay, cool. NPM fund. I have no idea. I think it's to where does it say that somewhere? Oh, right here. I'm guessing, but yeah, I think you pay money to help fund projects. And I guess there's, you know, there and apparently there's 12 packages that are looking for funding. So like you invest into them or whatever, you give them support for their open source projects. I've never used it to be honest. That's kind of an asshole thing, right? I should probably support something. I support my dog. It's okay. But yeah, yeah, I guess that's npm fund. I don't know. Let's try it. But did I type it like drains my bank account? Would be funny. So yeah, I guess you can just go to these, figure out what these projects do. Be pretty cool. That's a good way to start up fund. I never saw that before. Pretty. So if you think that this person's project is cool, you could give them 25 bucks or whatever they're asking for. That's cool. Pretty cool way. I didn't see that before. Live in my own world. Okay, plenty of time. But I know we've been talking straight. But again, I like this lecture. I think it's one of my more favorite ones. But let's start this web server. So we have our dependencies. We know how that works. We know how IP addresses kind of work. We know how DNS works. We're going to build a server finally. And it's not that difficult to start out. And I'm just going to, if you're following along, I'll drop this code in Discord, or you can just type it as I go, or you can grab it from Web322. But I'm going to load up our Express library. And the code looks like this. And all this does, I start commenting this stuff right away. So I like, require the Express module. And this basically just loads all of those library files for, better words, but into this Express variable. And then I'm going to instantiate a new object called app. Now we could call this server because it's going to be the web server. You call it web server, but I would have called it web server. But I'm going to stay with what our website says, and I'm going to instantiate Express. And this is like where OOP comes in, right? So like if I was instantiating a person in C# or whatever, it would look something like this, right? This is just instantiating a new server using Express. They don't use the new keyword, probably it's a static or something, but anyway, this is what this is doing. So get the app object. And now we have tons of stuff that we can do inside of app. And you'll notice some words that in there get, I don't know, set. Tons of stuff in here. And if you think about web servers, and I always say this whenever I see programs, whether it's like, your TV is software in it, someone had to program that. So I always think about how does that work? And that can lead you to think up new ideas, all this, right? Well, how does the web server work? Well, a web server, it's listening on a port. We know that it's going to listen on whatever port I'm going to tell this thing to listen to. And it just sits there and it spins and it's in a do while loop. In fact, if you go into the Express code, you can probably find a do while loop. And it's just saying do while there's a request, or well, there's not a request. And as soon as a request comes in, that loop breaks and it does some processing, right? So we don't actually have to put this in a while. It's actually in the OOP and it's called listen. So I can say, let's listen on port 8080 and oops. And I'm actually just gonna put a console.log to say the server is running. Server like that. Web server. So if you got this far, let me drop this code here. If you got this far, you can go down to the terminal. In fact, yeah, go to the terminal and then type node index dot or sorry, server.js. I'm gonna type nodemon because I have nodemon installed. If you remember nodemon, if I as soon as I save a file, it'll automatically reload the server. If you make a change in this JS file, you would have to stop your server and then restart it. So I like to use nodemon. Anyway, if this works, you should see server running. And I'm gonna make it a little bit easier for me later because again, I'm gonna be lazy. I'm gonna put HTTP localhost. One thing about localhost, every computer that has a network card has localhost, but it not necessarily has the name localhost, but it most definitely has this address. So your local computer, whatever it is, has an IP address of 127.0.0.1. So localhost is actually the our computer also has an internal DNS. So our internal DNS for 127.0.0.1 is localhost, but we could also, use that IP address. But I'll use localhost because that's what we're used to. And then I'm going to say on what port. I'm going to make a variable for port as well. So let's do HTTP port. Equals 8080. And you might see in the code on the web 322, I think it does process.env HTTP port. All this is doing, I don't think it even says on the website, but you can have environment variables, meaning I can set up my VS Code and Node to have default things like HTTP port because I use that all the time. So this code is actually just saying check if this exists. If it doesn't, then use port 80. That's why you'll see it on that site, or 8080. But I'm going to make it a variable because I want to use it here. And I also want to use it here because when I run this server now, I can use my mouse to highlight HTTP localhost and hold down command or control. And now I can follow it. Yeah, again, just being kind of lazy. I'll post this code. You can make this port whatever you want. Things are like things to note. If I'm running a server on 8080 and I have another node open or you forgot, like say this happens quite a bit. I have a node console and you could run this program twice and you could even close this window by accident. If you try to run two versions of 8080, it won't run for you. And the error doesn't really tell you too much. So just be careful you don't have multiple things running. Anyway, if this worked, you should get a web page that looks like this. And you're like, well, it says cannot get slash. We call or like in the industry, sometimes you call it whack, index, home, whatever. But if you see this cannot get slash or home or index, you're good to go. Your server is technically running. If I stop my server, you would actually get something this site cannot be reached. So if you got this far, let me know. I'll give you another 30 seconds or whatever, but you should have this cannot get slash right now. Anyone get there? I updated the code, by the way, in Discord. You get it? You got it? I shall wait. What if we don't have nodemon? Just run node then. Just do node in server.js. It just means when you make a change up here, you'll have to save the file and then go back to terminal and you'll have to use control C to kill the server. And then you'll have to restart it. But I'm pretty sure you could just do npm install nodemon. I'm pretty sure. Let me go check for it if you want to install it, that is. Looks like Nathan has it.
Yeah, it works for me.
Cool. Let me just look up the NodeMon thing. NodeMon. Nice. Okay, thank you. Yeah, the dash G would be global, so it wouldn't just be install on your one uh, on your one program. What was that? A duck? Someone has a duck. Yeah. A few people got it running, I guess. Yeah. Cool. Okay.
So
Yep.
downloading that NodeMon
Yep.
will put it in the package.json of every file now, or
If you do
every.
the dash G, like I don't know what the actual command is. Hopefully these are right. Kevin looks like he has it. It won't put it. It shouldn't put in your package.json if you did the dash G or the dash save dev. If you didn't do it, it would put it in your package.json. So to be specific, I installed it globally. That's why you don't see it in my dependencies because I want to use it all the time on different projects. But since that's how you run, since you can run it with just regular Node, it's not a requirement for our project. You know what I mean?
So does it become downloaded like as an extension on Visual Studio Code?
I think so, yeah. Or it wouldn't be in Visual Studio Code, it would be in the Node runtime.
Okay.
If you look in the Zoom chat, you'll see a link to it. Thank you for putting that link. It is super handy, Node one for sure. Okay. So hopefully you guys get this running so far, but it's kind of a useless web server because we just have cannot get slash, right? And just notice the keywords. We went through all that rigmarole of, all of this stuff and get requests because, now you understand that what's happening cannot get slash. So first things first, we have to program our get. So I'm going to do app dot and then get. And this is just a function, right? And I'm going to say, I'd like to program. Sometimes again, I can just keep, I hate, I'll call it home, like index, whatever. Sometimes we call it home, index, root, slash, whack. I don't know, whatever. So we're doing it for slash, and we're going to say, I'll come back to what this means in a moment. And someone just pooped on the microphone. Right, something like this. And so notice I'm going to program now our web server to say if someone tries to get the index or home, then I would like to respond. That's what res is with the string hello world. So if I save this program, and if you're running NodeMon, it should automatically reload, and I refresh the website, we get hello world. Do me a favor, if you're not talking, just mute yourself and then you can talk and unmute yourself. I don't want to hear people eating lunch and stuff. I'm just kidding. Okay. So if you got this, right? So, but check this out. We have now full control over this web server. In fact, if I right click and go view source code, you can see there's just that one line of source code. Larry, mine's not working. Can you update the code on the Discord? Sure. I can do that. Larry, you say yours isn't working. Do you have an error message that we can look at? And I updated on Discord. If you can show us your message, I can help you out. Drop it into the general chat in Discord, or maybe you can send it here. I don't know. Hopefully you have Discord, or just tell me. Did anyone get the hello world working? I'm assuming if you use my code, it should work. Cool. All right. So remember I said our web server, it sends when I ask for the get, and I wonder if I can undo here. Hold on. Might have just ruined all of this. So client, server. Oh, left. Larry X. Let's see. Hold on 1 second. Oh yeah, see, there's a prime example. Let's look at the error together, right? So it says whatever MacBook Pro, node events 497, unhandled error event. What's the next line say? Right? What's that say? What do you think the error is? It's basically what I just said before when I said you could accidentally have two of these running. So you probably have one of these running already somewhere because it says address already in use 8080, right? So there's a server that's localhost 8080 somewhere running. Your options are change the port or go find um, that other instance you have running on your computer. Let us know if you fix that. Okay, so this line we programmed this, or we programmed the response. I'm saying get me index slash server says yeah. I'm gonna send it back, and it doesn't care, right? Like the server does not give a shit if it's HTML or JSON or whatever it is. At the end of the day, it's sending back a string. The browser recognizes what it is and then turns it into something, right? So if you think about what's happening on these websites, we're sending back something like this, HTML body, whatever, H1 world. Right. If I save this and refresh the page, should get a hello world with some more closer valid source code, but really it's again just a string. But that would be a real pain if I had to do that. Well, actually, before I come back to that, let's pretend or let's imagine I also ask you to make, say, a contact page, right? So localhost 8080 slash contact. So we cannot get contact. So it's real simple, as you probably imagine. I would just, instead of having the whack, I would have contact here, and then we could say hello contact. Oops. All right, so now when I refresh, I get my hello contact page. Larry, did you get that fixed?
He's working on it.
So anyway, so this would be terrible if we had to program our web pages like this. This would be total garbage, right? Because I mentioned putting all of your HTML into this. Well, the good news is we have control of this now. So if you put in a console.log, and I'm going to say hello index, and I'm also going to do hello contact down here. And I'm going to refresh my index page, hello world, and notice what's happening, right? So I'm over here in the web browser. I'm going to click refresh, and that sends a request to our server. And I know some of you probably already know this, but I drill this into your heads because, a server can be anywhere in the world. It just so happens that our browser and our server are on the same computer. But when I do this, this is asking our server for something, and I can control that on the server. So when I refresh this, it's actually going to write hello index down in my server, right? So technically, every time I refresh this, I'm controlling the server from the web browser. Yeah, their code update. Okay. Let's do live code updates. There you go. Yeah, nice. Larry, you had two things running, right? Make sure you read those error messages, right? Because it kind of told you right in there. Just keep an eye on that kind of stuff. Okay, so this is cool, right? So now I can go to contact and notice that this fire is here, right? And so the browser like even though I have them side by side, just put it in your brain. Oh shit, I'm actually connecting to the server. The server is doing stuff. Like you could pretend this is over on Vercel. In fact, you could upload this now to Vercel and you could hit this refresh button on your browser. And then in the Vercel logs, you should be able to see the console.log, which is pretty badass. You're now controlling a server somewhere else in the universe, which is pretty cool. Right. And this is how stuff works. Like at this point, remember I said, like at the end of the day, when I run this send command, it's just sending back a string. And the browser, and this is true for everything. Like CNN, it's just this is still pumping out stuff. That's crazy, isn't it? It's just sending back a string and the browser parses it, right? Same thing happens here. But the cool thing is what you can do now. So inside of this index, when I refresh it, I don't just have to send HTML back. I could actually do something like connect to a database, get blog posts or whatever, um, loop through the through the blog posts array and create HTML, and then send back all of that HTML as a string. And then over on our browser, we get a whole web page with a blog post that are in our database, right? So that's how all this works. Like I think it's awesome when you put it this way. It's not like super impressive. If I just gave you this code and you hit refresh, but knowing all that stuff, how the router works, how those connections happen, this is so awesome because you are halfway or more than halfway from being able to create Facebook by yourself. Like think about the power that you could have. If you have an idea now for a website, you could probably go program that, which I think is awesome. Anyhow, couple last things, and I will let you go because I know there was tons to like get your head around today. But this is the most annoying part. I would never want to send um, just strings, but as programmers, we can do stuff, and that stuff is I'm going to make this like an MVC application. So I'm going to make a new folder. And I'm just going to call it views because in MVC, MV views, typically the views are whatever it is that we're working with, a screen, or in this case, HTML. And all I want to do is I want to get a HTML file called whatever it is, index.html, and put it into, and I'll just send it directly back and send it to the user. So I'm going to write some code that does this. First, I'm going to make the index.html file, right? And by the way, what I'm trying to say, in Visual Studio, VS Code, if you press Shift and exclamation mark, press Enter, you get a very basic, valid HTML. So here's my index page. And I'm going to make one for contact. Thing. And if you recall, At the start of the semester, I was like, Node comes with some predefined OOP items that are useful or functions. And Node works on these things called absolute file folders. Does anyone know what an absolute versus a relative folder is? Can someone tell me what the difference is? What's the difference between absolute and relative? I know you've heard of the terms probably at least. Any guesses? What's an absolute file folder? Nobody knows this? Not static. Um, it is static, kind of, right? It's absolute. So a common error I see in a lot of first year students when they're making a web page. Let's say we wanted to insert an image, right? IMG src equals whatever the image is called. A super common mistake will be the student will put C user area scanline wherever their project is, whatever, right? And that they'll say, and they will work on their computer because this is an absolute path, right? It goes exactly to that whatever.jpg. But when this loads up in someone else's web page, yeah, full path. I don't have that folder structure at all. So my browser can't find it. I always nail students with this. They lose a mark on that all the time. And this would never work on the internet because you don't know what someone else's folder is, right? So we have relative paths, which means this, if I type this image src code like this whatever .jpg should be relative to wherever the file is that I'm typing it in. So for example, it should be in the same folder that index.html is in. So absolute is the full path to where whatever. Thank you for that, Jenna. For that file, and then relative path is it's in the same folder. Now in Node, when we deal with files, we have to use absolute paths. But the problem is the same that when you hand in your project, I'm not going to have a C users, get a whatever projects something. I'm not going to have this. So in order for you to in order for this web server to find these files, we can't, I'll rephrase, Node will not let us use relative paths. So we have to use an absolute path somehow, but not make it static. Okay, so I know it's tough. I just wanted to kind of explain it, but the code is simple. So the first thing that we have to do is there's a built-in function to get the absolute path, and it's const path equals require path. And this gives us a bunch of OOP functions inside a path. And we can do um let's do it right here actually. So I'm gonna do res.send file, and I'm gonna do path.join. So join is like to join two strings together. And the first string that I'm gonna join together is the directory name. And the second one will be wherever the file is that I want to send. So in this case, it's views index, but I only have to put the relative path as this, but this path.join dir name will make it an absolute path. So I know I keep saying path and now it sounds funny to me, but you'll figure this out as you go. It's a common mistake. Anyway, all I'm doing is I included this get the path and then this join. This is just a string function. So if I did this right, I should get our index page, which I do. And now if I right click and go view page source, I get the valid HTML. So that's much more handy because now I can go inside of this file and edit stuff, right? Way handier. And yes, I will update the code. Give me 1 second. Let me just do the exact same for um, our contact page. Right. So if this works, yeah, there we go. I'll drop this into Discord. That should be good. I won't drop in these files, but if you're copying my code right now, don't forget, you have to make the views folder and you have to make these two files or whatever you want to call them. Shit, what did I forget? Oh yeah, okay. Hopefully you get, let me know in the chat if you get it to work, but I'll still talk here for a second. So this get, this home index root or whatever, and this contact one, usually I comment it like this, get, and then whatever it is, contact. Same for this one. It's a get, and then this will be index. But these things actually have specific names. And does anyone know what this is called when you have a get, or say, for example, we're going to program a post. When we tell this where to go, I'll rephrase, when we ask our server to get contact, it goes in here. Server looks through all of the code and looks for contact and then sends back whatever I tell it to, right? That has a specific word in here. Does anyone have a, I don't know, if you know, you would know, yes. But I'll just put it this way. When you take a bus home, what is the bus doing? It's going down a what? Someone knows now. A bus request? No, like a bus route, right? Bus route. So these are called routes, like this. And they call it that, right? So that it knows where it goes. A request is a good guess, I guess. I just didn't mean to laugh. It's been a long day. But yeah, these are the request is this. Oh shit, did my computer just freeze? Oh, you guys still see me? My computer froze. Oh yeah, route, right. So they're called routes. So this is the request, and then the server looks for whatever route you're trying to take, right? In APIs, they also call this endpoints. So if we were programming an API, which we can now do really quickly, right? So I can do app.get um, API, I don't know, Bitcoin stuff, Bitcoin, right? And again, this is pretty badass cool because you could now make your own API today for an app that you're creating, right? Just by doing something like this. Um, check this out. Specifically, Node or Express has a JSON uh, response, so I could make something like var, I don't know, prices equals, Bitcoin price. I'm just making this up. I wish it was 12,000, right? Maybe whatever. And I can send back this prices via our program. And this is again it's called an endpoint as opposed to um, a route, but it's the same thing. So Bitcoin. And we can see now we have an API call. Pretty awesome, I think. What if my computer froze because of that? I pressed something over here that was like download. So this thing doesn't usually freeze. Anyway, that's cool, right? Because then you could, same thing here. Instead of making our own object, we could connect to a DB that gets prices. Maybe it's whatever. And then we could make our own API. Pretty cool. Okay, so route, endpoint, common words that we need to know in full stack web development. Any questions, any comments? And you can expand on this too. Oh, remember this before I let you go. What is there? Remember that this route for index and this route for contact, it doesn't care if our file is called index. In fact, .html is now irrelevant to us because I can actually make this dot whatever txt, and it doesn't have to be called index, right? This is just a file that our system is reading. right? So our server will parse this data inside of our actual server and then send it back to our browser as valid HTML with the headers, with the response codes. But I only call this index.html because that's what it always has been called. And, HTML is recognized by VS Code and all of this stuff, but technically it doesn't have to be. And it also doesn't have to be index. Like I said, this I could actually make this contact and make this one index. That's going to send back those files. And again, I just want to make you aware of that because I'm just calling it this for organization purposes, right? And you should do the same, but it doesn't have to be .html in this case. That's it for today. Later on, this is not even this is like just the tip of the iceberg. Um, you know, things like if I added a nav bar, let's say I do ahref home, which would be just slash, and then I add contact. Right. So if I have this page, now I have a nav bar up here, and then let's say I put it on the contact page too. Now I can surf between these two pages pretty easily, which is cool. But in a few weeks, I think it's 2 weeks, I'm going to show you how like painful this is because if we had 400 pages and I wanted to add a new link to that page, I would have to go through all 400 pages. So that's in a couple 2 weeks. We learn about templates and how that kind of stuff works. Anyway, that's it for today. I guess we did take up the full hour, but again, this is my favorite lecture on this topic anyway. But thanks for listening. Thanks for everyone who um, answered questions or asked questions.